My name is Rafał Kukliński, and I'm a senior manager of an Amazon text-to-speech team. And at the same time, I'm leading Amazon Development Center in Gdańsk in Poland. I'm also a general manager for Amazon Poly service. And today I have an honor and a pleasure to present the service and also present a case study of how to build application that talks together with the team of Amazon Rapids. So today Steve and Josiah are with me from the team who will present how they managed to integrate text-to-speech in the application. So let me get started with a short introduction about what to expect from this session. We will start from short introduction about Amazon Poly, about what this service is about, how it works and what it offers out of the box. We will also present and refresh for some of you the information how to get most out of Poly. We'll present some use cases for using the Poly service and also the levels of complexity on how the service might be integrated. And then we will switch to the Amazon Rapids team to get their presentation about how they managed to integrate the service, what best practices they can share, and how it works in action. So let's start with the presentation about Amazon Poly. So what is the service? Amazon Poly basically is a service that converts text into lifelike speech. It offers 47 voices and 24 languages. And you as a customer can store, replay, distribute generated speech, so you can embed generated audio files into your application or into your device and distribute, or simply play with the service and use the generated speech in runtime. A few words about what the service offers out of the box. I would like to focus on the quality of the speech which we are producing. And to provide this introduction, I would like to give you some short introduction about what is the quality in terms of speech, in terms of speech synthesis. So basically, there are three main areas of quality for text-to-speech system. First is naturalness of speech. So how close generated speech is to real human generated speech or speech from a real human being. Let me play a sample which would best probably illustrate that.
Alice was beginning to get very tired of sitting by her sister on the bank, and of having nothing to do. Once or twice she had peeped into the book her sister was reading, but it had no pictures or conversations in it. And what is the use of a book, thought Alice, without pictures or conversations?
So as you can hear, the generated speech is very natural, and thanks to the algorithm and thanks to the deep learning mechanism we have in the service, we are able to generate the speech which intonation of the speech is mapped with the content with the semantics of the text. We measure naturalness of the speech through the subjective tests. So basically, we are asking a huge group of users to rate naturalness of a speech, and we do it in a blind test. So we are mixing the output of a text-to-speech system with the real human speech, so the recordings of real voice talent. And in this blind test, we asked end users and customers to rate the naturalness. And whenever the speech is close enough to speech generated by the system is close enough to real human speech, we perceive system as natural enough. Second factor or second dimension of quality in terms of text-to-speech system is accuracy of text processing. So what accuracy of text processing means is simply how we will be able to interpret the various structures in the text, like acronyms, abbreviation, numbers, and so on. So let me show you two examples of that. Here's the first one.
1 pint 8 ounces, 24 fluid ounces 710 milliliters.
So as you can hear, we are able to interpret various strange constructions, very strange structures in the text in an appropriate way, so in a way like a human being would do that. Let me play a different example, which is slightly different type of.
St. Mary's Church is on 226 St. Mary's Street.
So here, as you can see, we have a slightly different situation. So again, we have numbers, we have abbreviations, which needs to be pronounced and interpreted correctly. The difference is that we have here also the example of homography. So there is ST, abbreviation ST, which is interpreted and pronounced differently depending on the context. So we are able to also disambiguate text on the basis of the context and understand which version of the expansion should be used in this case. And third element and third dimension of the quality of the text-to-speech system is intelligibility. So let me play an example.
Peter Piper picked a peck of pickled peppers.
So that's an example of a tongue twister where text-to-speech is able to pronounce correctly and in an intelligible way, in a comprehensible way, the speech which got produced. So that's what we are offering out of the box, what Poly offers out of the box. On the 27th of March, we made a webinar about how to get most out of Poly. You can check it also on the YouTube, and by the way, the link to this webinar I will also display on the last slide, so you will get it. On this webinar, we presented how we can get more value out of Poly, so what kind of changes we can do. So let me start with the punctuation. We presented there on the webinar that punctuation is really a powerful tool. So let me play you two examples where first one does not have enough punctuation and the second one has all the punctuation which we would expect from a text-to-speech system. So let me play both and you will be able to notice what is the difference. Let's start from the first one.
He went to Harvard, and when he decided to drop out, it was not to find enlightenment with an Indian guru but to start a computer software company.
So as you can hear, the text is also, let's say, understandable, comprehensible. However, there is quite a lot of words and quite a lot of data provided. So let me play the second example.
He went to Harvard, and when he decided to drop out, it was not to find enlightenment with an Indian guru, but to start a computer software company.
So the same text, appropriate punctuation provides gives you a lot of difference in terms of how you are able to comprehend the text. Second example and second type of improvements or customization we presented on the webinar about how to get most out of Poly were examples with lexicons. So here's the pronunciation of word David. Let me play you first the sample how Poly sounds out of the box.
Here's my friend David.
So here's the presentation of the pronunciation of word David, but you can think about customizing this. Maybe in your case you prefer pronunciation David. So it's possible with lexicons to do something like this.
Here's my friend David.
So as you can hear this, you can change the way how the particular proper names, for example, or other names which are specific to the domain are pronounced. Third example shows you the use of SSML, which allows you to influence how the speech is being rendered. So whether it's set a bit louder or whether it's set a bit faster. So let me play you two examples of that.
When I wake up, I speak quite slowly. When I am in a hurry, I speak very fast.
So as you can hear with SSML, you can change the way how the speech rate is being rendered and how the speed of audio is rendered. A few words about Poly use cases. So basically we have lots of use cases for text-to-speech. Few of them are, I would say, iconic or quite often the cases and quite often observed by us in our interaction with customers. One is obviously the contact centers. So for the telephony systems, whenever you interact with the customer, you expect also you may use also text-to-speech to respond to customer and provide lifelike responses to your questions. Good example is Amazon Connect, so the AWS service, which is an AWS contact center and which uses Amazon Poly. Second use case are training materials. We have plenty of examples also within Amazon and also externally, of course, of people who are preparing training materials or courses to their employees, and those training materials might be voiced using Poly. We had also a great example of GoAnimate, who presented with us during reInvent the tool to create training materials and presentations. Third use case are content creators. So whenever you would like to synthesize or to provide ebook or news in the spoken form, you can use text-to-speech service to voice your content. Education and e-learning systems, and here's the example of Rapids, which we'll disclose or present in a minute. Education and e-learning cases when you are using text-to-speech to learn languages or to present educational content is also quite often the case, quite often use case. Internet of Things, when you use text-to-speech service to simply voice your system and voice your elements of the Internet of Things system. And last but not least, gaming and entertainment solutions are also customers for text-to-speech cases, for text-to-speech system. You might think of, or you might also see the presentation of Amazon Lumberyard on Game Development Conference, which used our Amazon Poly service for a gaming and entertainment solution. Let me scan through few, let's say, levels of complexity on how you can integrate Poly. So first of all, obviously languages. So in your application, you might use only English, you might use whole portfolio of 24 languages. Voices. So again, you might stick to one single voice in your application or use the larger variety of voices to imitate either dialogues or more complicated interactions. Lexicons, depending if you would like to customize a pronunciation for a particular domain or not. SSML tags, so you can use text-to-speech out of the box, but you can also use SSML to modulate the rate of speech or the pitch of the voice. Automation, so obviously we expose console where you can synthesize speech and generate audio samples, which later you can use, integrate with your solution and use in it. Or you can integrate with API and even generate speech in runtime and generate speech at scale. And last but not least, audio storage. So either you can regenerate speech and request for speech every time you need it, or you can cache and reuse speech if that's required by your application or you find it more beneficial for your application. Today, we are presenting a case study from Amazon Rapids. So from other Amazon team which used Poly for their purposes. This is a mix of education and entertainment use case. And here's how Amazon Rapids uses our service in terms of complexity. So they basically use lots of dialects of of English, lots of voices, and provide some customizations with SSML, some automation. And today I have a pleasure to invite and to ask for this presentation Josiah and Steve, who will show you how they managed to make the integration with the text-to-speech system. Josiah, Steve, floor is yours.
Thanks, Rafal. Hello, I'm Josiah Jordan. I'm an SDE on the Amazon Rapids team. I've been working there for about a year and a half now. I'm going to start by telling you a little about what Amazon Rapids is. We're a subscription-based reading application for kids 12 and under. We have original short stories. They're perfect for kids on the go. Each story is written exclusively for our app for this unique chat-style format. I'll start by giving you a video to help introduce what Rapids is.
Introducing Amazon Rapids, a fun new reading app for kids. Stories come to life, one message at a time. Explore hundreds of exclusive short stories with dozens more added every month. Amazon Rapids. Try it for free today.
So while we're still a young reading app with only original content, we already have several hundred stories to choose from in a variety of genres for readers of varying ages and reading capabilities. We're also continuously growing our library. We add new stories every week and dozens more per month. We also have some extra features that you'd want in an electronic reader. We have a built-in glossary, which allows our readers to quickly look up the definition for any word in our story and save those definitions for later reference in the app. Any word in the story can just be tapped on to hear it pronounced. And for a more guided experience while reading, Each story can be read aloud by our application. That's where we involved Polly. So we wanted to include reading functionality to help give younger readers access to our stories. The point of our app is to have fun. We want to make reading as easy as possible for every one of our readers so that the stories themselves can do their job and entertain. So why Polly? Well, we didn't actually launch with Polly included. Instead, we just used the available TTS that's available on each platform we were on. That was Android, Kindle Fire, and iOS. Each platform not only has its own text-to-speech engine, but also empowers the user to choose the voice they want to use for it. So we never knew what we were going to get when our listeners were hearing our stories because each user had their own unique setup. Additionally, we got a lot of feedback that people liked our read-along feature, even so much that they didn't even want the app without having that. But the voices themselves sounded a little too robotic for them, and we knew we needed to do better. We needed a way to bring our stories to life with voice in a better way. We needed it to work on all platforms and be entertaining to our users, but we also had to be scalable to our story load, all those hundreds of stories that we'd had to go back and fix. Plus, we're adding more every week, and we have 2 to 4 speakers in each story, sometimes even more than that. And we're not slowing down at this rate. The timing worked out great for us with Polly's release. Suddenly we had access to this library of high-quality voices to use from the cloud. Not only that, but we had the ability to customize the speech and do it once for all users and have a consistent cross-platform experience. Here's a quick example of Polly being used in our stories. This story that I'm going to play a video of, the first little bit of it, is called Ruin Rangers. It's about some kids playing a tabletop game in their parents' basement. One of their little brothers wants to join in. He's got a character from a video game version of the game that he wants to use.
Seth, can I play Ruin Rangers with you? Can I?
No, little bro. You'll just mess everything up.
Relax, Seth.
Do you know how to play, Adam?
I play the video game. Can I be my online character? Tell me about him. He's a level 95 Axe Master called Captain Kill Bloodline Awesome.
So here's a high-level overview of how we work with Polly. Well, first we upload stories to our service that's hosted on EC2, and we store that information in both DynamoDB and S3. We then send requests to synthesize the speech for each message in a story. We store generated audio files in S3, and then we reference those in DynamoDB. When a story is opened in our app fetches the story configuration from our service, and then downloads the appropriate audio for the story, and then the user is just playing that pre-generated audio of that text we generated earlier. So we have no developer involvement when we add new stories to our application, so just using the AWS console wasn't going to cut it for us. So in that sense, we needed to build a user interface to allow our content creators to create on their own. So the first step is they get their manuscript and they upload that to our admin tool. There's an automatic conversion process that happens where we take that initial just plain text and then store it in a format that we can use for our application later on with that unique message format. Next, our artists go in and we add all the associated images related to the story. After that, our editors and other content creators go in and they fill out a bunch of information like the author, some tags for the story, description, any other things you might need. After that, we start getting into Polly territory, or our text-to-speech. We assign individual voices to each of our characters in our story. We then can take that new knowledge where we've assigned voices per characters and generate speech files for every single message in each of our stories. So after that, we get that output, those output files, and we listen to each message to verify how it sounds. If something doesn't sound as entertaining as it should, we can do little tweaks and customizations to alter how the written text might sound to a text-to-speech engine and get it to sound more like we want to in our application. So the main goal with the UI was we wanted to incorporate what we got with Poly into our existing flow. Our goals for the new feature were to have seamless integration, no dev involvement in the process, as much automation as possible, and to enable rapid iteration on changes. So that's why when they're making these adjustments, we have the ability to quickly preview the audio so that they can make a small change, write some SSML, add some differences in the generated audio, and then quickly listen to that with that result just being streamed before so they don't have to store that. And they can change it as much as they want until they get it right, and then save that for use in the application. With that, I'm going to hand it off to Steve, and he's going to talk about how we, as one of our content creators, use the tool we built to create Poly audio.
Thanks, Josiah. Hi, my name is Steve Suey. I'm our art director on the Amazon Rapids project. So just to be upfront with you, I am not a coder by any means, so this should give you a pretty good example of how actually easy the integration was. So whenever you're at the point with your product and you've decided to integrate to Poly Tech, there's where do you begin? So there's a few things that helped us by asking these particular questions. The first thing was who is our customer? What was the age, gender, habits of the particular customer? And the what does your customer expect? I mean, when you have Poly integration, are they looking, consider things like quality, your pacing, do you want accents? I mean, do you want to cover all kinds of foreign languages? And then the next thing is where the gauge lies on emotional versus informational presentation of what Poly can do for you. Is it more of a entertainment versus utilitarian presentation in your voices? So we'll get more into that a little later. And then again, ask what does your target output sound like? So that meant actually doing a lot of demo phrases and finding exactly what that target is. So the development team, whenever we're doing the processing and integration of words, we know what to hit. And then lastly, the how is you would develop for your team an integration percentage breakdown. It's like, okay, it's Poly out of the box versus customizations. And so that will in turn tell you how much dev work is required. So for us, our answers to those things were, for the customer, we have readers with mobile means between the ages of 5 and 12. So imagine what that looks like. Imagine what that, the mental capacity and how those kids read. Customer expectations, reading is both an educational as well as an entertaining experience. So instead of us just having a linear experience of reading, there's a component of entertainment. So the presentation, and so that's exactly what we're talking about there, is it's probably about 70% emotional and 30% informational, where it wants to be entertaining. And so that's why Poly was such a boon for us, is just it had the ability to do that, where other solutions did not. And we have an audio example, which we set as a target. So.
My people stupid. Especially Goblin King. He my big brother. He loud, smelly, dumb, ugly.
So that was our target, and that was from the Ruin Ranges story that we heard earlier. And so our development, our our integration percentage was 90% poly we were using out of the box. 10% was customizations that we decided were important to us. Pacing was a big consideration there. So moving on to the next slide. Did I miss a slide? Oh, sorry. Okay. So for us, I mean, I've processed, I did a lot of this story integration, probably close to most of it. And so what we've come up with is a list of best practices that work for us between the poly integration and how it works with our product Rapids. So what I would suggest, especially if you're using multiple characters and considering multiple characters, is identify the ideal cast for roles. And what I mean by that is Poly has 47, voices to choose from. So we would categorize the voices into what we would need. Is like, okay, these work best for a boy or a girl. This works best for a teen boy or girl, an adult male, adult female. We even have aliens and ghosts in our stories. So we had created a casting list of poly voices, and that really helped us along. Another thing to consider, written does not necessarily equate to verbal presentation. I think that was demonstrated earlier in Rafal's quote that he had. Just because the written is correct in its use of commas, colons, periods, that doesn't mean that it's necessarily going to come across in the way that you're going to want to present it. So be aware of that. Also, customizations. So like I said, we had 10% that we were doing on poly customizations, and that was a combination of SSML, which we used actually very limited use of it. We got a lot right out of the box. What we did mostly was do some pacing with a lot of punctuation. So the colons, the commas, the periods, the question marks, those were all very useful and very simple to understand. Another thing to consider is variations in pronunciation. So how quickly you want things to be sounded out. Sometimes, Poly is very good at enunciating, but sometimes you want a very casual conversation to come up. And so the phrases like about you, where, if you phonetically write that out, it's about you or about you. And so it gives more of a slangish approach to things. And so we did a lot of that in order to make sure that our characters were well represented. And so again, the phonetic creativity that you're used, that you can use, especially like if you want to do something perhaps with a character with a New York accent, where instead of saying nine, they would say noin. And so get really creative about that. There's some really fun things that we did to produce those sounds. Also, if you have in your story something like a computer beep or something that's going off, that is very much doable by doing some SSML integration as well as phonetic creativity. So, to give you an example of one of our stories that we've used for integration, we have a story, it's called Coffee. And this is the story of a child wanting to try coffee for the very first time from his reluctant mother. And I'm sure we've all been in this situation. But so what I'm going to do is I'm going to play the first example here. And this is before the child has actually eaten coffee, or drank coffee, sorry.
But I thought I wouldn't like it at first, remember? You made me try it, and now I love it.
Now that was Poly straight out of the box. There was no SSML to that. child's voice did a really good job for us. So it hit the target that we were trying to achieve. Next slide here. Hold on. Okay, so the next one was basically, I'm calling this example on coffee. So our expectation that we're trying to drive on this was we wanted the child to talk at a faster rate, higher pitch. They're all amped up on, the caffeine. So this was the syntax that was used, very simple. We increased the rate by 30% and increased the pitch by 20. So here's the example of that.
Am I talking loud? I can't even tell. I should get dressed. I'll be right back. Bye, Mom. Bye, Mom.
So quickly talking, the same child amped up. So, and finally, we get to the coffee crash, the infamous coffee crash, and the mother even counts down in the story. She's like, coffee crash coming in 3, 2, 1. And so what does that mean? That means that you want to lower the rate of delivery, the pitch is lower. So here's an example of that.
Oh man, there was so much I wanted to do today.
So we've had a lot of fun with the project, as you can tell. So I'm going to turn it back over to, this is
Sorry. Thanks, Steve. So what do we learn from doing this? One of the things, like the biggest takeaway I think was that it was just so easy to integrate with Poly itself. What did that take? It was, well, we were already using Amazon Web Services. We had calls to go to DynamoDB, we had calls to go to S3 and do things, right? So it's just you do an action on a bucket, you do an action on a table. This was you do an action to Poly. It's just the same interface as every other service. Create speech, that's it, you're done. You get back the streaming audio and you do whatever you want with it. We chose to take that audio stream and store it as an MP3 file in S3. Next, with the cast of voices we had available, we were able to actually, do some modifications on these voices via post-processing, totally outside what Poly offers itself, but it's more like these voices are extensible by just altering the audio afterwards. So we were able to take our cast of characters up to the 20s of English voices with various things like multiple boys, multiple girls, multiple adult males, special funny characters like Little Chipmunk or an alien or a ghost. And you're able to do that just with any kind of post-processing audio tool that you might find. Because, we're an entertainment app, proof listening to our audio and going over it line by line before we give it to our users was like, it showed amazing improvement in the quality of audio that we were able to get. So it's not just about, for us narrating the story or providing a way that you can hear it. It's about making it a fun, entertaining, engaging experience. And by doing this, instead of doing it on the fly at real time, we're able to have it the same for everyone and we know what it's going to be. Additionally, it allows us to, cache that audio so we don't have to generate it every time either. And finally, even with the 500 plus stories and all we're adding for the tweaks that people do and customizations when they're trying to rapidly iterate on it. So with that, that concludes the rapid stuff. So let me hand it back to Rafal to close us out.
Amazon Rapids is a new app to help kids develop a love for reading.
But we heard from you that our read-along audio needed some work.
At launch, we used voice technology that already existed on your phone or tablet.
But from your feedback, we quickly learned that it sounded too robotic, and a single voice wasn't great for storytelling.
So we searched internally here at Amazon for a solution, which we found in the technology called Amazon Poly.
So now, Amazon Rapids has evolved from a single robotic voice
into a full cast of characters.
It's pretty obvious you're an alien. I mean, spaceships. Invasion?
It's pretty obvious you're an alien. I mean, spaceships, invasion.
So why are we excited?
Because now we offer more immersive storytelling for young readers and better pronunciation when using read-along.
Amazon Rapids is always working to improve our service.
So let us know what you'd like to see us work on next.
Start your free trial today.
And thank you to all the audience for listening and for participating in this webinar. A few information I would like to share with you. So first of all, contacts with any questions about this webinar or Poly in general on the email polywebinars feedback. We are happy to hear your feedback and to simply make use of it. So make our service better. You have also contact to Amazon Rapids team. So whenever you would like to contact Rapids team and ask some questions, you can do it through their website. Few links which we are sharing here. First, introducing Amazon Poly at reInvent, so introduction of the service and the background technology there. I encourage you also to see our other webinars. On the previous webinars, we shared how to voice your blog and build application which reads the content of your blog, and how to get most out of Poly. And here is also the Poly Rapids video, which we encourage you to see, as it's simply cool. That's how we perceive it. Let me go through some of the questions which were asked during this webinar. So let me just open the appropriate window. So there were a few questions. So one was, does accurate text processing works also in other languages, for instance, STR Straße in German? So yes, we build the language models for every language. We build the text interpretation and text normalization for every language we release. So that's available out of the box. Exactly like also SSML tagging. So also the SSML tagging and also the lexicons are available for every language which we support. There was another question about, is it more cost effective to call the Poly API directly from an application as opposed to caching and raising the speech? Well, it depends on the use case. It depends mainly how many prompts you want to generate. So the functionality is basically exactly the same in the console and in the API. Depends whether you want, for example, with reusing and caching the speech, if you have lots of repetition of the same sample, probably you would prefer to reuse it and cache it. If you are creating a content which has the speech embedded, you need to reuse it and cache it, or store it as a part of your content. If you need to run kind of runtime dynamic application, probably Alexa is a perfect case, you probably want to call API directly with every request for speech. Another question, when will Lex choice of languages match Poly? Well, the Lex is using Poly for voice output, so you can select the voices for the languages which are supported by Lex, all the voices which are available with Poly. There was a question about, is caching provided by Poly or is it something we have to build into our application? So there are so many, on the basis of our experience and our interaction with customers, there are so many ways to cache speech, part of the speech, whole samples. Some people integrate the speech into their output, that it probably is virtually impossible to provide the caching mechanism which would work for everybody. So let's say Poly allows you to cache and store the speech. The caching, the way how you would cache it depends on you and depends on your application. So you need to build it in your application. There was a question, does SSML allow you to place emphasis on a specific syllable? So let's see, there are two parts of that, of the answer to that. One is that there is possibility to use SSML, there is a tag called emphasis to emphasize particular word in a sentence. There is an SSML tag for that simply because there's a way to show which is the prominent word in the speech. And the prominent word in the speech quite often depends on your particular situation in your particular case, right? For example, you can imagine the sentence, this is red dog. to have emphasis on dog because dog is important, or red because red is important. And by the way, the situation is really abstract. There is also a possibility to put emphasis on syllable using either the phoneme tagging, so provide the phonetic transcription with the stress symbol, or through use of lexicon when you want permanently to have a word, to have a stress on a different syllable in a word. So you can use the phoneme tag or lexicons. Another question, what is the baseline dialect used for American or British English? Is there a plan to build any other dialects? So I would say that it depends on the requests from customers. So we are listening to customers, and whenever we have such requests and such requirements from customers, we will prioritize accordingly. British English, with British English and American, we were looking for dialects which are, say, requested by customers. We had also a funny trick on the previous webinar, Get Most Out of Poly, how to change the dialect of our US English voice. I encourage you to look at it. It's one of the last slides on the presentation. There was a question, how would you estimate using Poly versus using live actors in terms of time and costs? Well, I would say it's quite obvious that the cost of Poly is much lower. Let's say, I won't maybe share the sums which we have with the voice talents which we worked with, because those differ. But obviously the amount of hours which you need to put into recordings with voice talent, the fact that you need to bring voice talent to the studio and record whole sample quite often, several times, that's obviously a difference by order of magnitude. What do you do in proof listening? What do you tweak if tweaks are required? Is it voices, prosody features, something else? Yes, we listen to all those items. When we are proof listening our audio, we are checking in fact, all those items, or those elements, so prosody features, the way how we normalize text, all those items affect the quality of output, the quality of speech. So we are listening to all those items when building our voices. And I believe that's what is this question about. There was a question, I do understand that Poly is faster in production and cheaper. I wonder still how would cost compare for a typical rapid story? I would say that's a matter of calculation. So I had a question from Rapid's team that the stories are around 1,000 words. So if you will calculate per character, the cost would be really minimal, and obviously you will fit in the free tier. So costs are below cent. And I got question, is there a way to get timestamps of when each word begins in the speech generated by Poly? So at the moment there is no such functionality available. However, again, so that's a valid feedback and we'll prioritize it accordingly. Oh, there is one more. How long does it take to get a rapid story through Poly on average, including all the work you do on customizing SML and proof listening? Is it a matter of days, hours, weeks? Probably I would need help from the Rapids team. Let me ask this question. I got the question. About 45 minutes to do all the work for SML, as little as 20 minutes. So that's the answer. So rather a matter of minutes than days. I don't see, we have lots of other questions, but I believe I covered those which were most most impacting. So thank you very much for participating in this webinar, and thank you for joining us today.